Hello and welcome back. Today our topic is probability using counting techniques. And our learning goal together would be at the end of the note and after completing your homework, I can extend my understanding of basic probability, so the previous lesson, and use the various counting techniques that you discussed in Unit 1. So for the most part today, the lesson is going to involve examples because it's just using previously known material. So just a quick review here, the basic probability formula. Remember that the probability of event A occurring is determined by taking the number of ways our successful event could occur, so N of A, and dividing it by the number of total outcomes, so NS. So your total outcomes is your NS, and we call NA number of successes. And success is always a relative term. And we'll talk about that as we get a little bit further along. So what we're going to be doing, we're moving our formula toward dealing with the counting concept. So that formula that we just wrote up here, the probability of A equals NA over NS, our values of NA and NS are now going to be calculated a little bit different than they have been in the previous homework. So it's still, N of A is still our number of successes The difference now is that we're going to use factorials, permutations, combinations, tree diagrams, and whatever other tool you need to use to be successful. So no longer you're not limited to a dice question where there's only 2 or 3. Your N of S, total outcomes, and it still applies that we're going to be calculating NS and NA using all those concepts that we talked about in that first unit, similar to the first unit test. All right, so into some examples. So the first example deals with 3 coins being tossed one after another. Calculate the probability that, so A part, probability 3 heads will occur. So you can do this 2 different ways. If we use a tree diagram, some people might jump to that right away. So the tree diagram. So we have our first coin, our second, and our third. So the first one can either be a head or it can be a tail. Head or a tail. Head, tail, head, tail. Similarly below, head, tail, head, tail, head, tail. Tree diagram can be a little bit longer, but the nice thing with the tree diagram, if you're looking for a positive here, is that you can now answer A, B, and C all with that diagram. So the time that you used finding the tree diagram, you're now just going to use it for the remainder of this question. So for A part, we're looking at the probability of 3 heads, so 3H. So that's going to be the number, 3H possibilities, over total number of outcomes. So in order to find out how many times 3 heads occurred, there's only one path that provides a heads, heads, heads possibility. If you look at all the other paths, they involve a tail at some point. So for A part, there's only one possible way to get 3 heads. And if you count total number of outcomes, it's just counting how many ends or branch tips there are from your tree diagram. So 1, 2, 3, 6, 7, 8. So there is a 1/8 of a chance that you will flip 3 consecutive heads. All right. B part. A head and 2 tails will occur. So now when you do your pathways, you need to identify when you have 2 tails basically. So going through my pathways, I've got a tail and a tail. So I'll just put a star at the end of that one. So there's 2 tails. And where else do we have 2 tails? Got to go down below. Tail, tail, head. So there's another one. And I do not believe there's any other. So there's only the 2 ways in order to end up with your 2 tails. Tail, tail, heads. Oops, I'm sorry, I'm incorrect. There's one other path here. If you go tails, head, tails. So there's actually 3. So probability of 1 head plus 2 tails. So it's the number of ways you can get 1 head plus 2 tails divided by the total number of outcomes. Total number of outcomes, when you're dealing with a consistent problem like this, the total number of outcomes never change. It's always going to be over 8, unless the scenario changes, but you'll be moving on to a new question in that case. So now it's 3/8. So the probability of getting 1 head and 2 tails is 3/8. And finally, moving on to C part then. C, 2 coins are the same and the third is different. So an extension, and really it's just 2 the same. So 2 the same. N of S. N of S we know is over 8. We already know from the previous part, part B, that there are 3 cases where we had 2 tails. Now we just got to find the 2 heads. And some of you are already thinking, well, there's going to be some symmetry there, and you're correct. So in this case, here are a pathway with 2 heads. Here's a pathway with 2 heads. Here's a pathway with 2 heads. So we end up with 6/8. That was our answer. All right, so there is how to do this particular question with a tree diagram. So you can see that for the first part there, with the tree diagram, you spend time making the tree diagram. However, when you look at the answers, you are simply just reading numbers from the tree diagram. There's no calculations. You've done all the hard work. So if you don't mind doing the hard work up first or do the tree diagram first, the method works quite well. I just want to show, I'm not going to do this for everyone. I'm going to show the alternate method then. If you don't want to use a tree diagram, so I'll put an OR here. So if you didn't want to use a tree diagram, so A part, 3 heads will occur. So when you're looking at the 3 heads, and we'll do it with this method, if they all 3 have to be heads, so this is my N of A, N of A, there's only one way that can occur. Your N of S would be the total number of outcomes. So for that first slot, it could be a head or a tail. So there's 2 options, head or a tail, head or a tail, which gives us 8. So the probability of 3 heads is equal to 1/8. So you can see it's very, very similar, but now you're not using the tree diagram. Going back to one of the other processes we used, kind of the pictorial process. B part, a head and 2 tails occur. So we already know N of S, that's not going to change. So 1 head, 2 tails. So we already know it's going to be over 8. So this situation where we have a head and 2 tails, we then approach it. We approach it from the sense of we're really dealing with 3 items here. We're dealing with a head and 2 tails. So maybe if I back it up, and I apologize, think of it this way. You have a head and 2 tails. So here's your pool of numbers or letters. How many ways can we arrange them in this order? So we have 3 options times 2 options times 1. However, you need to remember that you are dealing with clones here. So we end up with 3 factorial divided by 2 factorial, which is 3. So our answer for B part would be 3/8. So now you're doing arrangements using identical items or clones from the previous unit. And finally, the last one, C part, you're now looking at two the same. And again, you can still use B part, and you know that tail, head, head is going to be the same calculation. 3 factorial over 2 factorial equals 3. So therefore, you have 3 plus 3 is 6, which is your number of possible outcomes. So the probability in this case would be, so 2 the same would equal 6 over 8. So you can see there's a little bit more thinking involved in terms of the setup. Okay, but you get the same answer, so it's the same approach. So I'm not going to do this for all the following examples. I'm going to go with one method. Both are equally correct when it comes to marking, so it's just a matter of going with what you're comfortable with and what you know best. So we'll continue with a couple more examples in the next video.